Hi students, welcome back. This is Chemistry Lecture Chapter 6, Section 5, Part 3, and the final part of this chapter. I know it's been really grueling, it's very theoretical also, a lot of new terms, VSEPR, electron dot, Lewis structures, hybridization, and then we talk about metallic bonds and all kinds of different things, ionic bonds, covalent bonds. Um, don't get bogged down on it, just try to understand it simplistically. These are terms that are theoretical, but yet if you really look at them from a simple point of view, um, hopefully you'll be able to take something out of this chapter and be able to apply it to the chemistry that will happen with the chapters yet to come. Anyway, this section begins with G, intermolecular forces. Now, number one, kinetic energy increases as liquid is heated. At boiling point, energy is sufficient to overcome the forces of attraction between liquid particles. The particles pull away and enter the gas phase. Number two, the boiling point measures the force of attraction between particles of a liquid. Higher boiling point, the stronger the forces between the particles. Number three, intermolecular forces are forces of attraction between molecules. These forces are weaker than molecular and ionic. Table 6-7, page 190, shows the values of ionic compounds and metals are much higher than those for molecular substances. Number four, molecular polarity and dipole-dipole forces. Under A, strongest intermolecular forces exist between polar molecules. Under B, dipole created by equal but opposite charges that are separated by a short distance. Under C, direction of dipole is from positive to negative pole, which is represented by an arrow pointing toward the negative pole and cross tail at the positive pole. D, negative pole of one polar molecules attracts the positive pole of another polar molecules throughout molecules in liquid or solids. Under E, dipole-dipole forces are forces of attraction between polar molecules. These are short-range forces between nearby molecules. These forces will cause higher boiling points. Figure 6-21, page 191. Under F, polarity of diatomic molecules are determined by one bond, but with more than two atoms, molecular polarity depends on both the polarity and orientation of each bond. Under G, water is bent and highly polar. Figure 6-26, page 191. Ammonia is highly polar, creating a net molecular dipole. Under H, in some molecules, individual bond dipoles cancel one another, so polarity is zero. CO2 and CCl4 are examples of non-polar molecules with polar bonds. I, polar molecules can induce a dipole in non-polar molecules, temporarily attracting its electrons. This is a short range and weaker than dipole-dipole forces. This allows the oxygen, the O2, to be soluble in water. See figure 6-27, page 192. Number 5, hydrogen bonds. Under A, HF, H2O, and NH3 are unusually high boiling point due to a particularly strong type of dipole-dipole force. B, there is a large electronegative difference between hydrogen and the fluorine, oxygen, and nitrogen atoms, making the bonds highly polar. The hydrogen becomes positive and small size. C. Hydrogen bonding, the intermolecular force in which a hydrogen atom that is bonded to a highly electronegative atom is attracted to an unshared pair of electrons of an electronegative atom in a nearby molecule. D. Hydrogen bonds are represented by dotted lines. Figure 6-24. Number 6, London dispersion forces. Under A, nonpolar molecules and noble gas atoms can form weak intermolecular attraction to make them liquid or solid because electrons are in continuous motion. Electron distribution may be slightly uneven. B. These momentary uneven charge with or will create positive pole and negative pole in another. This holds the molecule's atoms for an instant by weak attraction. Figure 6-29, page 193. Under C, London dispersion forces are intermolecular attractions resulting from the constant motion of electrons and creation of instantaneous dipoles. Proposed in 1930 by Fritz London, these have low boiling points. Under D, the strength increases with the number of electrons in atoms or molecules, so London forces increasing with atomic or molecular mass. This can be shown by comparing the boiling point in helium, which has less mass and a low boiling point, argon, hydrogen, oxygen, and chlorine, and bromine, which actually has a more mass or higher boiling point. This concludes our lecture for Chemistry Chapter 6-5, Part 3, and the end of Chapter 6. The test will be coming soon. Thank you very much.